guys, this is Mrs. Bolin with your notes for 8.1, Solving Systems by Graphing. So for the warm-up, the question is find the slope and y-intercept. If you guys will remember, we have y equals mx plus b, tells us our slope-intercept form. And remember that the m is the slope and the b is the y-intercept. So in this case, m is 8, right? There they are. So slope equals 8. And then the b is plus b at the end, but we have a minus 2 right there. So we know that the y-intercept is actually a -2. That's it. We didn't even have to do any math on that one. Okay, question number 2 says find the x-intercept and the y-intercept. So remember that if I want to find the x-intercept, I could put 0 in for y. Okay, and we use a little shortcut called the cover-up method. Mathematically, that's not a thing. You can't just cover things up. But if we're putting in a 0 right there, that makes this whole product equal to 0. And if we're adding 0, it doesn't change the x at all. Okay, so if I'm putting a 0 for y, I can just do that x equals -6. So we're going to, even though there's a greater than right here, we're going to use an equals because we're trying to find that one value to find what x is equal to when y is 0. We're going to do the same thing for y. I'm going to put a 0 for the x. So that essentially is going to go away. So I have 3y is equal to -6. Divide by 3. So y is equal to -2. So we found the x and y intercepts. We're done. Okay, question number 3. We are going to graph that. First, I'm going to find where x is equal to -3. And so if you guys remember, this is the x-axis. So I'm going to find the value when x is equal to 3. Now, if y is 0, x equals 3. If y is 1, x equals 3. If y is 2, x equals 3. No matter what y is, x will always be equal to 3. And so what that looks like is a vertical line through the x-axis at 3. Okay, question number 4. Oh, sorry, that got crooked. Is 3, 5 a solution to this equation? Well, remember, it goes in alphabetical order. Okay, so first they tell us the x value, then the y value. So if we're going to plug in, we're going to take the 3 and pop it in for x. We're going to take the 5 and plug it in for y. So I'm going to rewrite that with those values. 5 is equal to -3 plus 8. So 5 is equal to 5. That is true. So yes, this is a solution because when I plug in those values for x and y, it makes my equation true. Okay, so today we're going to learn about systems of equations. And a system of equations just means that we have more than one. And it has the same variables. This time we're just doing x's and y's. So we are going to look at what it means to have a solution to a system. So the solution is a point that works in both equations. Okay, and so there's several ways to solve that algebraically. There's a few different methods. Today we're going to look at the method of graphing. And the solution where both of those equations are true would be that one point where they overlap. So their intersection point. So first we're going to see if they give us that point, we're going to be able to tell them, yes, this is a solution or no. And then we're going to say, well, here's the equations, find the solution. We're going to do that by graphing. So for the first one, remember how I told you this is x and this is y. We're going to plug it in, okay? So the first one, and here's my two equations that I'm trying to see if it's a solution for the system, it has to work for both of them. Okay, so I'm going to plug it in. So I've got x is 2, y is 5, and I want to know, does that equal 7? Well, yeah, 2 plus 5 is 7. That is equal to 7. So that's true, but I have to check the second one. Okay, so 2 times 2 minus 3 times 5, does that equal -11? Again, I just plugged in the 2 for x and the 5 for y. So 2 times 2 is 4. 3 times 5 is 15. There's a minus right there, so that stays negative because I was multiplying it by a positive, equals -11. Well, that is true. -11 equals -11. So because it is true for both equations, then I would say yes, 2, 5 is a solution to the system of linear equations. Okay, let's try another one. These ones were written in standard form. These ones are written in slope-intercept form where the y is by itself. Okay, so again, this is x, this is y. I'll switch to a different color so it's easy to see when we switch. Okay, so instead of y, we're going to plug in a 0, -2. Instead of x, we're going to plug in a -2. I know it's kind of confusing. There's a -2 out in front, and we're plugging a -2 in. Make sure you guys use parentheses. That way you can tell, is it being multiplied? Is it being subtracted? And then I need to make sure I copy that -4 at the end. So 0 is equal to negative times a negative is a positive. 4 take away 4 is 0. So yes, it works in the first equation, but I still need to plug it into that second one and see if that's true. So now I'm going to plug in y is 0, x is -2. So 0 equals +2. Is that true? No, it is not true. So even though this point worked in the first one, if it doesn't work in both of them, not a solution. Okay, so no, it's not a solution. All right, question number 3 in our practice. We are going to solve the system by graphing. Remember, excuse me, if we have y equals mx plus b, this is where we begin, and we always begin on the y-axis. We start with our up and down. And then the m is how we move, okay? And it's the rise over the run. So for this first equation, we'll graph that one in green. We're going to begin at +5, and then we're going to go down 2. And if there's ever not a fraction, you can just put over 1. So we're going to go down 2 over 1. The negative tells us up or down, and we're always going to go left to right like we're reading or writing. So down 2 over 1, down 2 over 1. You can keep doing that all the way across. And that's one of the equations. Then for our other equation, we are going to begin at -1 on the y-axis. And then we're going to do the slope, which is +4 over 1. So we're going to go up 1, 2, 3, 4 over 1. Now here's the important part, you guys. Right now, I haven't solved anything. I graphed 2 equations, but the solution to this system is the point where the lines intersect. So I have to give that answer, and I always write it as an ordered pair. So I'm going to say the solution to this system of equations would be when I go over 1 for the x, when my input is 1, and my output or my y value is 3. So that is my answer. The graph is the work. That's not my answer. It's the work. The 1, 3, when x equals 1 and y equals 3, that's my answer. Okay, so make sure you guys don't forget that, a very, very, very important step at the end. Okay, question number 4, we're going to do the same thing. Whoops, that was blue. Okay, so we're going to start with this green one. We begin at 1. We go up 1 over 2, up 1 over 2. And we can also do the opposite. If we go down 1, then we have to go backwards 2. So if you want to get some more points, you can do that same pattern. And then for the next one, we are going to begin at 5, and then we're going to go down by 3, over by 2. So down 1, 2, 3, over by 2. All right, and remember, the point where they cross is my answer. So this one is 2, 2. Okay, as we're going through this, you guys should be pausing the video, trying the problem on your own, and then press play to get the right answer, and then just fix your workbook, okay? So these are guided practice problems in class time. I would give you guys a little bit of think time to try it on your own, but because this is just a video that you guys can hit pause on, I want you guys to do that, try the problem, and then see if you got it right, okay? So for 3 and 4, those were written in slope-intercept form, which makes graphing them super fast and easy. For question 5 and 6, these are written in standard form. So instead of being able to use the slope and y-intercept, we need to find the x and y-intercepts. So remember how in the warm-up we talked about the cover-up method? So if I had x plus y equals 2, and I cover up or put a 0 in for the y, I get x equals 2. If I do the same thing for the x, I plug in a 0 for x, then I would get y equals 2. Now I'm just going to graph those two dots. X equals 2, y equals 2, and that's my line. So some students like this way a little bit better because you don't have to worry about slope and do I start on x, do I start on y? It tells you where to go. X is 2, y is 2. Plot them, connect the points, okay? Now I'm going to do the same thing for the other equation that's going to be a little bit more difficult. Is if I plug in a 0 right there, I get 2x equals 1. 2x equals 1. This one's going to have a fraction in it. So x equals 0.5. Now I'm going to do the same thing for y, and here's where you guys need to be super careful. Okay, if I cover up that 2x, I get negative y equals 1. I can't leave it like that because the y isn't by itself yet. So I need to divide both sides by negative 1, or you could just switch the signs on both sides. So y equals negative 1. So I'm going to plot that x equals 0.5, y equals negative 1. And I'm going to kind of follow that same pattern. This went up by 1 over by a half. So I'm going to go up by 1 over by a half. And if we extend that out, it intersects the graph, not at one of the points we made, but it does cross at where those little gray lines cross, and that's at the point 1, 1. That one's a little bit harder because it didn't go through exactly at a whole number for our x-intercept. But if you guys saw how I kind of followed that pattern to a point that does, it makes it a little bit easier. Okay, question number 6 here, same thing. Oops, I guess I don't need to scoot it over, huh? All right, so I'm gonna start by plugging in a 0 for y in this top equation. So I'm just gonna get x equals negative 2. That one was easy. Then I'm going to do the same thing for y. I'm going to put a 0 in where the x is. And so I get, that was a plus, so I can cover it up. I get 2y equals negative 2. So 2y equals negative 2. And then if I want to get the y by itself, I just have to divide. And so I get negative 1. So I'm going to plot those. X equals negative 2. Y equals negative 1. Remember that x goes side to side. The y goes up and down. So I'm going to plot those points. And we're gonna just kind of extend that same pattern, a few more dots. And I'm gonna try to go through the dots. Sometimes my lines don't look very straight on here. Okay, and then we're gonna do the same thing for the x and the y on this other one. If I plug in a 0 for y, that part goes away, and I just get 4x equals negative 8. Divide by the 4, so x is negative 2. Then I'm going to do the same thing for the y. So I'm going to plug in there, but we have a negative, so that has to stick to it. So negative 4y equals negative 8. When I divide by the negative 4, I get y equals a positive 2. Okay, so I'm going to go x equals negative 2 and y equals positive 2, and then I'm going to connect the dots. Okay, so the point where they cross here would be negative 2 on the x, but then it didn't go up or down, so that's 0 for the y value. Okay, that's it for your notes. I'm going to go over the answers to the odd questions for your homework, and make sure you guys copy down all of the work so that you can take a picture at the end. Make sure you're trying the even problems in between, and then enter all of the answers in Canvas, okay? So here we go with your homework assignment. And if I'm going too fast, just hit pause. All right, question number 1 says, tell whether an ordered pair is a solution to the system. Again, this is our x and our y, so we're just going to plop those in for both of them. So x is 2, I'm on this top one right now. Y is 6, and I want to see, does that equal 8? Yes, it works on the top one. Okay, so let's check the bottom equation. I have 3, do my work up here, 3 times x, which is 2, minus y, which is 6, equals 0. So 3 times 2 is 6. 6 take away 6 is 0. 0 equals 0. And you guys notice here, I'm not like solving the equations. I'm not going plus 6 on both sides. I'm just simplifying each side of it. And so if I get something at the end that is true, I know on both of them that yes, this is a solution to the system of linear equations. Question number 2, I'm going to do the same thing. Remember, this is x and this is y. So when I start plugging it into that top one, instead of writing the y, I'm going to write a 1. Instead of writing the X, I'm going to put in a -2. Oh, just kidding. I'm supposed to be doing the odd ones, you guys. I'll just finish writing this real quick, +6. Okay, you guys finish that, and then you're going to plug in the same point again to the second equation. Okay, so for question 3, we're going to use the graph to solve. This one's my favorite one because look, you guys, it already graphed it for us. So all we have to do is find where they cross and then write it as an ordered pair. Okay, so the answer for this one would be, okay, it went over 1, 2, 3, and then it went up by 2. So 3, 2. All we had to do for that one was count. Super easy, right? Okay. Question number 4. Can't get me again. I'm going to skip that one because I'm just doing the odds. But if you guys had to do this one, this would be cover-up method. Remember, you would go like 2x equals 4 and solve it. And then you go -2y equals 4 and solve it. You do that on both of them, graph those on just the x and y intercepts. Okay, you guys can do that one on your own. Look back at problems 5 and 6 if you need help with that one. Question number 5, we're going to graph that. For this top equation, we are going to begin at 4. So 1, 2, 3, 4. We are going to go down 1 over 1. If there's no number here, you can say there's 1x, right? So we can say, well, that's, and since it's negative, we go down 1 over 1. So we're going to put all those dots in there. Pretend like that's a nice straight line. I might have gone off course there a bit. All right, for this other one, we are going to begin at -8. Remember, we always begin on the y-axis because it's our y-intercept. Okay, so I'm going to begin at -8. So 2, 4, 6, 8. And then I'm going to go up by 2 over 1. And I'm going to keep doing that until I hit this other line. Okay, because I'm not the best at drawing lines, but I can keep doing that same pattern, right, until it runs into the other one. So my answer now is the point where they cross, and that my line went a little bit off there, but it's supposed to cross through that point, which was 1, 2, 3, 4, and up by 0. That was the answer. Okay, question 6, we're going to skip. You're going to do this problem exactly the same. Begin, go up 3 over 4. Begin at 6, go down 1 over 2. Okay, find where they cross. Make sure the answer is this point where they intersect. Okay, question number 7 says, describe and correct the error. The solution of the linear system is x equals 2. Okay, that's kind of right. It's half right, right? Let's see, make sure they graphed it correctly. So we started at -1, we went up 2 over 1, up 2 over 1. That looks great. This one, we started at 1 and went up 1 over 1. That looks great. But remember, the solution has an input and an output. So yes, when x is 2, but also when y is 3. So the way that we give our answer is 2, 3. Okay, we want to make sure that we give both parts of the answer. All right, question number 8. How many solutions does it have? I'm going to let you use your best guess on that one. You don't even have to give what it is. I'm not going to answer it because it's an odd problem. You guys, or sorry, it's not an odd problem. It's an even problem. You guys can figure that one out on your own. But I just put a dot where the solution is. The other lines that are on there are just the x and y axes. Okay, so that is it for today, and I will see you tomorrow.